Hi, this is Mrs. Milton. I am going to be the one making the videos for Chapter 7, so it will be my voice that you are hearing. I look forward to working with you and hope you are all doing well. This first section is called Polynomials. A little vocabulary to talk about, this would be worth writing down, is when we have polynomials, there's lots of different numbers we'll talk about. The first set we're going to talk about is the idea of a coefficient. A coefficient is the number in front of your variable, which is multiplying. If you look, there's an invisible math multiplication here between the 2 and the x, invisible multiplication here between the 4 and the x, and invisible multiplication here. So our coefficients in this polynomial are a 2, a 4, and a 6. Then different degrees we have going on. Degrees are the exponents. Oops, sorry about that. Let's try that again. Are the exponents of 3, 5, and 7. So in this problem, we have exponents, degrees of 3, 5, and 7. Now terms are a little bit different. We have 3 terms. We have a term here, a term here, and a term here. The terms are separated by the addition and subtraction sign. So we have an addition sign here and an addition sign here that separates our this grouping into 3 different terms. So I'm going to write that's a term, that is a term. Ooh, I got to work on my writing. My goal is to get better at that. And then to finish up, we have just our polynomial. So when you put this all together, your polynomial is a bunch of terms put together as one. So this polynomial has 3 groups of terms. A 2x cubed would be our first term. Our second term is 4x to the 5th, and our third term is 6x to the 7th. All right, continuing on. Here we have monomials. A monomial is just when you have one term. If you look, the 3 isn't separated. There's not something else here that was adding or subtracting. This 3 times x, there was nothing here that was adding or subtracting, so they're called monomials. Now the degree of these monomials is basically, you look at the sum of the exponents. So if you look at 3, there is no exponent. A constant will always have a degree of 0. If you look at 3x, well, this x really has an exponent of 1. That's some imaginary, or not imaginary, invisible math. So we have a degree of 1. 3x squared y to the cubed. Now notice it says the degree is the sum of the exponents on the variables. So if you look here, we have a degree or an exponent of 2 and another one of 3. Well, 2 plus 3 is 5. So that monomial will have a degree of 5. And then to finish, the negative 12, x to the 4th, y to the 5th, z. Well, that z has invisible math exponent of 1. So I have exponents of 4, 5, and 1. 4 plus 5 plus 1 is 9. So that monomial has a degree of 9. Now to talk about degree of polynomials. So you can see here, this polynomial has 1, 2, 3 terms separated by addition. And the second polynomial has 1, 2, 3, 4 terms. So let's spend some time and look at what the degree is going on for each of these. So if I look at the 4x squared y to the 1, that would have a degree of 3. 2xy, well, the x and the y both have exponents of 1. You add those up, that's a degree of 2. And then a constant does not have a degree, or it just has a degree of 0. So this polynomial, I picked the highest degree, which is 3. So the term with the highest degree gives you the degree of your polynomial. So if you look at the second example, we've got 7x to the 5th y. Well, that y has imaginary math there, a degree of 6 when you 5 plus 1. Here, 2 plus 2 is 4, x to the 1, so 1 plus 8 is 9, and a constant has a degree of 0. So the highest degree of the 4 terms, the highest degree is 9, so the polynomial has a degree of 9. All right, these next examples are what your homework is going to look like. It's going to say to write the polynomial in standard form and state the degree. Well, first thing we have to do is try to combine some like terms. I see this 3x to the third and this negative 4x to the third as being like terms because the coefficients of 3 and negative 4 both have an x to the third behind them. So to combine like terms, 3 minus 4 is a negative 1x to the third. And then I see this plus 2x squared. Well, there's no other coefficient that has an x squared behind it, so that's just going to come down. And then to finish, I see this constant of negative 5. That negative 5 can't combine it with anything. Now this is in standard form because you need the biggest degree listed first, and then you move down to the next smaller degree and you end with a constant. So I think this one is ready to go, and it is going to have a degree of 3 because of the 3 terms, 3 is the biggest degree. Let's try another one. All right, this one's pretty big. Let's try to figure out what our like terms are that we can combine. I see I have a positive 4k squared and a positive 2k squared. Those k squareds will be grouped together. I have a constant of negative 2. There's no other constant, so that will be on its own. I have this negative 7 coefficient that has k to the 5th. Well, nothing else has a k to the 5th, so that's by itself. And then this positive 3k to the 8th, that doesn't have any like terms either because there's no other k to the 8th. So now when it's time to write this out, my biggest exponent is that 3k to the 8th. So I'll write that first to get this in standard form. Whoa, I really got to work on that. Then my next biggest exponent is a negative 7k to the 5th. All right, now my k squareds, I've got this positive 4k squared and a positive 2k squared. So 4 plus 2 gives me a positive 6k squared, and then I will finish with that constant of a negative 2. So that is my polynomial in standard form, and it is going to have a degree of 8. All right, one more to go. All right, I'll try to go through this one a little bit faster. You pause if you need to. This 7 has an x squared y to the third behind it, and so does this negative 4 has an x squared y to the third behind it. Make sure you always look at the coefficient. Always look at the sign in front of it. The sign in front of it has to go with that number. So this isn't a 4, it's a negative 4. And then I've got a positive 2x and a positive 6x. The 2 and the 6 both have x's behind them, so they are going to be like terms. So the 7x squared y to the third is going to become a 3x squared y to the third. And then the 2x and the 6x will be a plus 8x. I feel pretty good about that because this 3x squared y to the third has a degree of 5. 2 plus 3 is 5. And this guy has a degree of 1 because there's really an x to the 1 there. So it's in standard form because the biggest degree is listed first. And it has a degree of 5. You list the biggest one. All right, I hope those examples help you to understand how to write polynomials in standard form. That's it for today's lesson. The homework assignment is on Schoology. Please complete it as soon as you can. Get help when you need it and upload it to Schoology. See you tomorrow.